Welcome to NCERT Science, Chapter 2, where we explore substances and learn about their acidic, basic, and neutral properties. Everything around us is made of matter, which can be living or non-living. Matter consists of tiny particles, and many substances in nature are chemicals. Chemical substances may be classified as acidic, basic, or neutral based on their properties. Acids are sour in taste, like lemon juice and vinegar. Bases are bitter and feel slippery, such as soap solution and baking soda. Since we cannot safely taste or touch every chemical, scientists use indicators, like litmus paper, to identify them. A chemical substance is acidic, basic, or neutral because of the ions it produces when dissolved in water. What is an ion? An ion is an atom with an electrical charge. Atoms are usually neutral, having the same number of positive protons and negative electrons. Losing an electron creates a positive ion, while gaining an electron forms a negative ion. Acids and bases are identified by the ions they produce in water. Acids release H+, or hydrogen ions, which are responsible for the acidic nature. Bases release OH-, or hydroxide ions, responsible for the basic nature. Ions are the building blocks of many materials. Because ions have electrical charges, opposite charges attract, helping to build compounds like table salt, which is made of Na+ and Cl- ions. pH is a numerical scale that helps measure the acidic, basic, or neutral nature of a solution. The pH scale ranges from 0 to 14. A pH of 7 is neutral, below 7 is acidic, and above 7 is basic. The lower the pH, the stronger the acid. The higher the pH, the stronger the base. This chart summarizes the properties of acids, bases, and neutral substances. Acids are sour and turn blue litmus red. Bases are bitter, slippery, and turn red litmus blue. Neutral substances are neither acid nor base and have no effect on litmus paper. Let's test your knowledge by matching the common items to the acids they contain. Take a moment to decide your match for each item. Here are the correct matches. Lemon juice contains citric acid. Amla contains ascorbic acid. Tamarind contains tartaric acid. And vinegar contains acetic acid. Knowledge of algae and fungi helps us understand the origin of litmus, a natural indicator. Algae are like tiny water plants that live in ponds, lakes, and oceans. They make their own food using sunlight. They range in size from microscopic to large seaweed. Fungus is not a plant. It's a natural recycler. Fungi, like mushrooms and yeast, absorb nutrients from their surroundings and help clean up nature by breaking down old materials into soil. Lichens are unique symbiotic organisms formed by a fungus and an alga living together. The alga makes food using sunlight, and the fungus provides protection and water, demonstrating a symbiotic relationship. Lichens grow on rocks and trees in areas with clean air and abundant rainfall. They come in many colors and are used to make litmus. Large, bushy lichens indicate super clean air. Litmus is a natural dye extracted from lichens that acts as an acid-base indicator. Acids turn blue litmus red, bases turn red litmus blue, and neutral substances keep the paper purple. Litmus paper production begins by harvesting and processing lichens to extract the litmus dye, which is a natural organism containing the dye. Next, the purple-colored litmus dye extract is obtained. Plain paper strips are dipped into this extract, and once allowed to dry, they become purple litmus paper. This sequence shows the steps to create purple litmus paper, from lichens to the dye extract, dipping the paper, and drying the final product. The purple litmus paper can then be treated with an acid to produce red litmus paper, or with a base to produce blue litmus paper. From nature's lichen, a powerful indicator is created to test acids and bases. Litmus paper is a common indicator. In acid, blue litmus turns red, while red litmus shows no change. In base, red litmus turns blue, and blue litmus shows no change. Beyond litmus, other natural indicators exist. The red rose, for example, is a natural acid-base indicator. On crushing red rose petals and steeping it in hot water, a purple-red extract is produced, which turns red in acid and green in bases. The hydrangea plant is another natural soil indicator. Its flowers turn blue in acidic soil and pink in basic soil, helping us understand the soil's properties. Turmeric, or haldi, acts as a natural indicator for bases. A yellow turmeric strip turns deep red-brown in the presence of a base, but remains yellow in acidic or neutral solutions. A neutralization reaction occurs when an acid and a base react, forming salt, water, and releasing heat, effectively canceling out each other's properties. During neutralization, the acid provides H+ ions, and the base provides OH- ions. These combine to form water. The remaining ions form salt, and energy is released as heat. An everyday example of neutralization is ant sting relief. The acidic sting is neutralized by a mild base, like baking soda, illustrating how acid plus base yields salt, water, and heat. Neutralization is essential for healthy agricultural soils. Lime, a base, is added to acidic soils to neutralize them, promoting better plant growth. Neutralization also contributes to cleaner water systems. Industrial wastewater is treated using neutralization before release to restore equilibrium in lakes and rivers. Whether on our skin, in our farms, or in our waterways, neutralization helps restore equilibrium. Acids and bases are not just science concepts, they are part of our daily lives. Antacids help relieve stomach acidity, soaps and detergents help us clean, pH testing supports farmers and doctors, and baking soda is useful in cooking and cleaning. Science is all around us every day. Can you identify an acid or a base just by using your nose? Olfactory indicators are substances that change their smell in acidic and basic solutions. Examples include onion, vanilla extract, and clove oil. Olfactory refers to the sense of smell. The chemicals responsible for the onion's smell react differently in acids and bases. The smell remains detectable in acids, but is no longer easily detected in bases. If nature gives us so much, how can we show our gratitude in return? Nature provides countless substances, each with its own properties. We have a primary responsibility to safeguard nature, respect its delicate balance, and be thankful for all it offers.